Okay, all right, this is the first day that I felt good in a long time, at least 4 or 5 days. So I'm gonna go until 10:30. What is it? Almost 10. Okay. All right. So let's see. I do have a calculator with me, so I can refer to that. I don't have my unit circle with me, so hopefully I got it firmly in my brain. So let's go ahead and start with number 1, and we'll just go. Maybe we might skip around. I'm counting on me prefacing this at the beginning of the hour today. Test review units. Okay, so let's find the reference angle. So remember, reference angles, basically, the reference angles are families. So if you have an angle that is greater than 0 to 90 degrees, then you need to convert it to a reference angle. Okay, so in radians that would be from 0 to pi over 2. All right, so you are just trying to figure out what family it belongs to. Okay, so this guy right here, he has the same reference angle as this angle here in quadrant 1. Okay, just because he's in quadrant 3 doesn't mean that he's any different than the same angle in quadrant 1. He's just going to be positive or negative depending on if you're curious about the sine, cosine, and tangent. I hope the audio is good on this because it's kind of far. It's kind of struggling still to use my voice, even though mentally I feel sharp. Anyways, let's see. I'm going negative 35 pi over 12. So let's figure out how many. Let's see. So let's take off one full cycle here. Okay, let's take off one full cycle. The one full cycle would be negative 24 pi over 12. Okay, so 35 minus 24. All right, that's going to give us, what is that, 11? Okay. All right, so this means then that I've got, I am negative 11 pi this way. I'm negative 11 pi over 12. And that's because I have taken 24 of those negative pi's off of my 35, okay? So when I have something like that, then that means that if I'm a negative 11 here, a full 180 is negative 12 pi over 12. So this means that I am 1/12 away from the end here. So this means that this guy has to be pi over 12. Okay? Just because he's, just because I'm negative 11 pi over 12 here means that this guy is going to have the same coordinates as this pi over 12. It's just an issue of whether or not he is positive or negative. Okay, if you're talking about sine, cosine, and tangent. So my answer here is pi over 12. All right, now over here, we got negative 61 pi over 18. Well, that's a lot of, let's see, that's 1.5. So I just have to figure out what this distance is right here. One way to look at it is how far are you from the x-axis? Okay, how many degrees are you? So we're going to have to take, we're going to have to subtract negative 61. Well, you know what? Let's just treat it as positive 61. Okay, just to not mess up and add double negatives. What we want to do is we want to go ahead and 18. If I were to double that, that's 36. Okay, so that would be negative 36 pi over 18 would take me a full circle. Okay, so what is that? Let's see. 25 pi over 18. Okay, so this means then that I've got 25 pi over 18. So this means that I've gone from here to here is negative 25 pi over 18. Now if I do this much, that is another 18. Okay, so let's take 25 and now let's minus 18 again because I need to get to that whole half of the full cycle there. So let's borrow one from there. So what was that, 7? Okay, that's 7 pi over 18. All right, now is 7 pi over 18, is that in between pi over 2? Let's see, pi over 2 would be 9 pi over 2, right? I'm sorry, 9 pi over 18 would be pi over 2. So this guy is smaller than pi over 2, even though it doesn't feel like it. But 7/8 over 18 is smaller than 1/2. Okay. So this means that this distance right here is actually 7 pi over 18. Okay, so that is your answer there. All right. Okay, find the exact value of each trigonometric function. So we got to figure out where this is on the unit circle. Now I know it's a pi over 6. Now the sign of pi over 6 family is always going to be 1/2. Okay. Now I'm halfway there to my answer. All I got to do is figure out what quadrant do I land on after I count all those pi over 6s. Okay. Whatever quadrant I'm in, I got a 50-50 chance of being right. I'm either positive or negative. But all this pi over 6 family for sine is always going to be 1/2. Okay. And you can look that up on your unit circle. So let's figure out how many pi over. Now I'm going to count negatively, so I'm going to go I'm going to go clockwise, and I'm going to actually be pretty careful here. What I'm going to do is I'm going to mark all of my pi over 6s. Now you know what? Nah, that's just kind of a waste of time. Let's do it like this. Okay, there's my pi over 6 family. Now I'm going to land on there somewhere. So negative. Okay, so this would be 6 pi over 6, 12 pi over 6, 18 pi over 6, 24 pi over 6. So 24 means that I'm right there at this guy right here. That would be 24 plus 5 more would take me right there. That's the quadrant. So what quadrant is that? That is sine positive or negative? He's negative. All right. He's negative there, so my answer is going to be negative 1/2. All right. So cosine. All right. Automatically pi over 4 family. So now I just got to count and figure out which one of these guys am I going to land on. So I know my answer is radical 2 over 2. Just where is he? Depending on what quadrant will determine whether or not he's positive or negative. But you already got a 50-50 shot, okay, if you think about this on the SAT, okay? All right, so we're going to count 21. So let's go, going full around would be 8 pi over 4. Then we're going to go another 8. That would be 16. Let's go another 8. 24 is too high. Okay, so we are at 16. So 16, 17, 18, 19, 20, 21. We're right there. Okay, now I just counted negatively the pi over 4s, okay, as we went around the circle. Now notice that I counted every one of these pi over 4s. Now that took me to the second quadrant, and cosine is negative there. Okay, so he is negative radical 2 over 2, okay, because he's in that quadrant. All right, now this is totally not using a calculator. This is totally using the unit circle. That's how powerful it is. All right, we're going to go ahead and do 5 and 6 here for the last one. Okay, so now I'm going to graph cosecant. Now this is a reciprocal function, so he's going to look funky. What I want to do is I want to graph his what he's related to, right? What he's a reciprocal of. Now he's a reciprocal of sine, okay? Now if you remember, sine looks like this. Now I have never committed to memory what cosecant looks at, never. All I've ever done is know and graph what he is not, okay? So let's graph sine as he normally would be if it was 3 sine theta, okay? And I'm gonna make sure that I graph my guy in blue, okay? My final answer will be in blue. Now let's make my final answer in pink because that's what everything else has been. All right, so let's graph 3 sine. Now, I don't see any action here in front of theta, so the period is just going to be 2 pi. So normal sine. It's just he's got an amplitude of 3, so let's go from 0 to 2 pi. Okay, that's 3 pi, so watch out for that. We know that sine hits there, and right in the middle, he's going to be 3. Okay, right over here, he's going to be -3. That pattern will continue as he marches across, and it looks like we don't need to go any further there. Okay, now what's nice about this is that cosecant, we know, wherever sine is 0, that's going to cause an asymptote to incur if you're going to graph cosecant. So these guys are going to have an asymptote wherever, wait a minute, I'm so sorry, I should have put a dot there. That was probably driving you crazy. You're probably going to yell at me. Let's make sure this is right. All right, that would be 0 there. This guy goes, let's go here. Remember when I was saying that I was mentally sharp right now? All right, so there we go. So wherever the sine function is 0, I graphed my sine in error, so that's why, and it looked wrong. So that's when you can always recover, because it's got a beautiful symmetry to it. Now, these are where the asymptotes are. So this guy will just be a hyperbolic shape right here, and this is as good as you need to get it. All right, this is just knowing how to generate that, knowing how to spot this in a crowd. Okay, if it's going to be on the SAT, this is what you would just be, you'd be given a group of graphs, and you'd have to figure out, does this match the options provided? Okay, and these guys rarely are on the SAT. They're definitely on the ACT. There's always a question involving that on the ACT, but SAT is hit or miss. All right, so last one here, we got secant that is related to cosine, so he's going to look like that, but we're going to graph him and just do what he is not. I said that I would put the answer in pink over here, didn't I? Oh, wow, I totally messed that up, but that's okay. You guys know what I'm talking about. We're going to do the period here, and the period is always going to be 2 pi over b, and b in this case is 1/2. So 2 pi divided by 1/2, there's 4 halves inside 2, so that's 4 pi. So this means that 4 pi is a full cycle for cosine, okay? So that's all we got to worry about, that 1/2 theta there. That's all that means. It's the same thing as doing that. Same thing, okay? And we've already taken care of that now. We know that we go from here to here. That's one full cycle. Okay, but cosine starts at his maximum and ends at his maximum, and unfortunately it's only 1/2. So if this is 1, I mean, we're talking pretty small here. He goes 1/2, and then at 4 pi he also is 1/2, and at 2 pi he is at his minimum. Okay, which means that he's going to hit his minimum again right here at 6 pi. And that looks symmetrical. Okay, so that means in the middle here, oh, no, see, I got to do 1/2. I didn't do 1/2. I did 1 1/2. Okay, so right there in the middle is 0. Right there in the middle is 0. Now those are where our asymptotes are. Okay, and secant and cosecant look just like each other. They start these guys at different locations because of what they're related to. So those are the asymptotes for us, and so it just means that these guys are going to kind of like look very U-ish. Okay, this guy is not part of our graph. It's a mistake. Okay, but they're going to kind of go real quick. They're not quadratics. I know I've said that before. Okay, so you kind of want to give them a little bit more of a flatter curve, but that's pretty much the essence of these guys. All right.